All right, so TMTA Algebra 2 2024 test. For some reason, I skipped over 26 and 27. They're not hard problems. So a security password is comprised of 5 digits from 0 to 9. The first digit cannot be a 0, and the third digit must be a 4. So what we're going to do is we're going to use the idea of I can be this, and this, and this, and this. And it's about the number of choices for each digit. That's what it's about. So your first digit has 10 choices, 0 through 9. If you count your fingers starting at 0, you'll count 10. There's 10 digits there. Sorry, it can't be a 0. So we have 9 choices. We have 10 choices on the second one. The third one must be a 4, so you only have one choice. And it's a 5-digit number, so now we have 10 and 10. That's all I got to do. Multiply those 3 strings together, and that looks to me like 9,000. Just make sure you read the text, all right? Look for the little details. First digit can't be a 0. Third digit had to be a 4. And there you go. It's not a hard problem. 27, let the revenue and cost functions for a company be given by revenue as a function of x is 400x minus a quarter of x squared, and cost as a function of x is 10x plus 7, where x is the number of units produced and revenue and cost of x are in thousands of dollars. What is the number of units that must be produced and sold to obtain the maximum profit? So profit is going to be simply revenue take away cost. That's what profit is. So my profit function here is going to be 400x minus 0.25x to the second minus 10x plus 7. And I need to be using parentheses, right? Because I'm taking away more than one thing. All right, so my profit as a function of x is going to be 400x take away 10x, which is 410x. And let me put this in standard form. Negative 0.25x to the second minus 410x minus 7. That's my profit as a function of x. Now, there's lots of ways of doing this thing. Let's see, x is given as the number of units. So I know that x is going to be opposite b over twice a. So x is going to be opposite b, 410 divided by twice a negative, it's because that is not negative, that is positive 390, dum-dum. All right, there we go. Negative 390 divided by, let me do parentheses here, parentheses 2 times negative 0.25. All right, that's going to give me a negative 390 divided by a negative 0.5, which is going to give me 780 units on the money. So, your generation kind of struggles with this concept of memorization. So, say I forget that. I'm holding a TI-84, right? I can literally graph the cost function, negative 0.25 x to the second plus 390x minus a 7, and then zoom 6. I'm trying to maximize profit. And I'm not going to see much of this graph. Like, it's just not going to happen. I've always trained y'all to look up and then right. So I'm going to go up 1,000 units and see if I see anything. I don't actually think I will, but who knows? I might have to go up 10,000, 20,000, 30,000. Oh yeah, this thing's going up and up and up. So let's go to 10,000. See if that's high enough. 10,000 is probably going to do it. All right, time to start looking right. Of course, we already have a maximum here. Let's just set the x max to 2,000. I should see the entire graph. No, I still had to go higher. Well, how about that? Will I at least see it come down? There we go. So let's set that y max to be 100,000. Let's add a 0. Higher yet. And here's the problem with looking at graphs. 300,000 is this, which intimidates a lot of children. So finally, a window setting of 300,000 on my y max and 2,000 on my x max gives me a good picture. I can go to second, trace. There is a maximum function right there. It's choice 4. And it's the whole left, right, enter thing. So get left of the maximum, press the enter key. Get right of the maximum, press the enter key, and enter for a guess. And it's going to say really close to 780. Calculator has rounding issues. It's just the way it is. All right, let's see where I stopped yesterday. I did that one. Oh, these problems. These always bug me. How many liters of a 20% chlorine solution should be mixed with 30 liters of a 50% chlorine solution to get a mixture that is 30% chlorine? So instead of showing this algebraically, let's work backwards, okay? Let's work backwards. Let's just kind of plug in some answer choices here. So I start with 30, and if I add 70, I'd have 100 liters, all right? Now, this was 50% chlorine, which means that we had 15 liters of chlorine, and 70 liters at 20% equals 14 liters of chlorine. Now, the goal is to get 30%, right? Well, if you take 15 and 14 out of the new 100, you get 29%. So it's like really, really close, isn't it? It's ridiculously close, but it's not what I'm looking for. All right, so let's maybe look at A. I've got 30. I add 60. I have 90 total liters, and it's a mixture. The 30 liters had 15 liters of chlorine. The 60 is 20% mixture, which is 12. So I get 12 liters of chlorine. I get 27 liters of chlorine. So I have 27 liters of chlorine out of 90 liters of the mixture. And that, I think, is it, because that's reducible. These are both divisible by what, 9? So this is 3 over 9, which is, sorry, that is 9 over 10. Sorry, they're both divisible by 9. It's 3 over 10. It's right there. So plug in and work backwards is a good strategy. The algebra on these is a little harder to set up. That's actually quite a bit harder to set up when you could just plug in answer choices. And that's exactly what I'd do on that one if I were you. 35, what is the other root of the equation x squared plus x plus c equals 0 if x equals 3 is a root? Okay. Well, if x equals 3 is a root, then this is the factor. I was just trying to think of the best way to do this. And there's another way of doing this too. I'll try and show you about 3 different ways on this one. The factor is x minus 3. What I want to do is I want to multiply it by something else so that I get x squared. Well, I'm not sure what I want to do there. But anyways, think about your foiling technique, negative 3x, and the goal of getting an x. What has to be here is a plus 4, which is why they put a there, right? That says x is negative 4, and there she is. Actually, I don't know because they have a good distractor at B, possibly. Yeah, really about the only thing you can do is figure out C. So I was going to show you two other ways of doing this, but this is the most clear way to do this, is just think about factoring. It's the most obvious thing that's popping in my head, all right? Just think about how it has to factor. 36, let f of x be a one-to-one function with domain of -4 to 3 and a range of 0 to infinity. What is the range of the inverse? So when they mention that this is a one-to-one, that means that whatever this graph is, see, it goes back to -4, the solid dot stops at 3, and the range is 0 to infinity. So whatever this function is, and I don't know what it looks like, it's passing, I'm just going to draw this, it's passing the horizontal line test. And most importantly, it has an inverse. Now, inverses do one thing, and one thing only. They swap x and y. At least that's the way we teach it in high school. We say swap x and y, because in high school, we're trying to teach everybody. If you look at the mathematical definition, is that we swap domain and range. That's what we do. We swap domain and we swap range. So we're just going to swap these two things around. The domain is going to be 0 to infinity, and the range is going to be -4 to 3. It's a legit, do I understand vocabulary? Do I know what an inverse is? Which is, I don't know how I'm supposed to constantly assess you for all this stuff and just get it to stick in your head. A light pole that is 15 feet tall casts a shadow that is 18 feet long. Ooh, we have some geometry here. So let's say the sun is up and it's casting a shadow. Here's a light pole. Here's my light pole. It is 15 foot tall. Its shadow, which would lie on the ground, is 18 feet long. And I also want to know what the shadow is for a light pole that is 10 feet tall is. Well, what I've done is I've created similar triangles. All right. It may not occur to you that you should draw a triangle in a scenario like this, but this is what's supposed to be taught to you in geometry, is the idea of solving similar triangles. And I'm not sure how the proportions were taught to you in geometry, but I've always done similar side to similar side as similar side as to similar side. So this 15 compares to 10, as this 18 compares to x. And I worked like I write. I worked left to right. Or I worked like I read, and I worked like whatever. I'm tired. Anywho, we do something old called cross multiplication. 15 times x is 15x. 10 times 18 is 180. Get over there. And then we just divide out the 15. And that should happen 12 times. Should happen 12 times. All right. So that's like an easy level geometry question. Super easy. This is not super easy. Like I've said in the other videos, the author of this test is not after a typical public school to win this thing. Because this is not taught. I think there's some honors geometry classes that might teach stuff like this across the state of Tennessee. Not in Weaver County, because our honors program is not done correctly. The truth is, the honors kids should only see me for 4 years. I should have you in a separate room where it's just you and me, and I can teach you 10% of what I know. All right? Instead of 3 or 4%, which is all you're getting. And if I did, you'd know how to do this. So it requires a buttload of memorization. It does. And there is sadly no real way to cheat on a calculator. There is, and I'll spend a lot more time on this than it's probably worth. But secant is the reciprocal of cosine. And secant is defined as 1 over cosine. We have tangent, which is defined as sine over cosine. And then we have cotangent, which is defined as cosine over sine. And there's another weird way of doing this that some kids fall back on, and it's just, oh, it's ugly, but it works, all right? So the weird way of falling back on things on this is to know that sine is opposite over hypotenuse, and maybe since you guys haven't seen trig identities, this is what I'm going to do. Cosine is adjacent over hypotenuse. Tangent, you guys know, is opposite over adjacent. I hate teaching things like this, but whatever. Cosecant, the reciprocal of sine, she's the hoe. In fact, you know what, let's just go with this. Secant is the reciprocal of cosine, it's the funny guy, ha. And cotangent is the reciprocal of tangent, so it's AO. So you know what, let's just go with this, even though it is inappropriate and the trig teacher in me is just absolutely frickin' cringing. This is probably your best chance. It really is. It's probably your absolute best chance. So, secant, I'm going to rewrite as ha. Sine is O over H. The denominator, tangent, is opposite over adjacent, plus cotangent, which is AO. All right, now, here's where it gets kind of fun. You are expected to remember your 5th grade math lessons. Those guys cancel. So the top becomes O over A. The bottom's where it's hard, all right? It's kind of hard to the bottom. You have to go back to like 3rd grade when people were asking you to do things like this, a half plus 3/5. Well, a half plus 3/5, we give this a 5 and we give this a 5, right? And we give this a 2 and we give this a 2, because in order to add 2 fractions together, you have to seek a common denominator. So we're going to have to do the same thing here with letters. So this guy's going to get an O, that guy's going to get an O, and this guy's going to get an A, and this guy's going to get an A. So I'm going to have O squared over OA plus A squared over OA. So I have O over A, sitting pretty over O squared A squared over OA, which I'm kind of glad the way this worked out, because I can do some reduction here. This will simplify, because what you have there is you have OA times OA over OA. So I can throw one of those away. So I have opposite over adjacent divided by opposite times adjacent. Weird, huh? All right. Boy, I don't like the way that worked out. I don't like doing things like this. That's just screwy. This is not how we do it in trig class. Anyway, so to multiply one fraction by another, or to divide a fraction by another, you multiply by its reciprocal. So the reciprocal of OA is 1 over OA. Okay, so it's gonna become absolutely meaningless. This is 1 over A squared, which is garbage. Fudge. I am really shocked, though, that that didn't work. Hypotenuse over adjacent times opposite over hypotenuse. Opposite over adjacent plus adjacent over opposite. O squared, A squared. Oh, because I'm an idiot. Right there. You can't put that together. That's O squared plus A squared, Benjamin. 5th grade math. Still struggling with it. All right, so to divide one fraction by another, we simply multiply by her reciprocal. And there is a little bit of a cancellation we can do here. It's that. So what I am left with is O squared over O squared plus A squared. So I did all of this and I got absolutely nowhere. Bummer. That stinks. So I'm going to stop this video, delete this section. Actually, you know what? Let's just leave it on here. There's a reason we don't teach this is how you do trig identities, and this is it right here. This is why we don't teach it that way. I've seen some kids do it successfully with smaller ones, and but yeah, it's just not doing it here. So let me do this one properly. This is where it's at. Secant is 1 over cosine times sine. We will do some work with here. Tangent is sine over cosine plus cotangent, which is cosine over sine. The numerator becomes sine over cosine, which is tangent. I may or may not do that later. This is going to become sine times sine, which is sine squared. This is going to be cosine times cosine, which is cosine squared. And that is sitting over sine cosine. All right, so I kind of weaned y'all off of formula quizzes because I got tired of it and I couldn't figure it out. But at the bottom of the form quiz, there's this one trig identity. It says sine squared plus cosine squared is 1. So let's see what we have here. And I'm going to leave this guy alone because I'm thinking a couple of moves ahead. I have sine over cosine, sitting pretty over 1 times sine times cosine, or sine cosine. Now I'm going to flip the denominator, cancel out the cosines, and I have sine squared. Now, what else could I do? Is it possible to kind of cheat with this on a calculator? Just a little bit. But you still have to know trig identities to some degree. All right, so it's going to be kind of a bear to type in here, but I'm going to go to math num n over d. I'm going to put my calculator, by the way, in radian mode, which it's in. Good. I do have to know that secant is 1 divided by cosine. I'm sorry I wasted 5 minutes of your time. I just don't have enough time to stop the video and do something. I was hoping that that would work because that would make more sense to y'all because you have not seen trig identities. And even though I'm going to do trig with y'all after your end of course test, you're still not going to see trig identities. So I typed in the bottom, tangent. We do have a tangent key, so I can hit tangent. I don't have a cotangent key, so I've got to know that cotangent is going to be 1 over tangent. Or I have to know that cotangent is cosine over sine. But I'm just going to do 1 over cotangent. Or 1 over tangent, sorry. Anyway, zoom 6. And this is a graph of what the function is. Yeah, that's what it ought to look like. Now, on a TI-84, you have to be careful about how you type trig functions in. There are certain things like with logarithms and trig functions that it doesn't do exponents the way we write them. So, like, I know the answer is sine squared because we just did it. But if I type it like this, the graph will not suggest that. Oh, actually, they fixed it. That didn't used to work. Huh. Well, I learned something. They fixed that. So look, perfect. It reduced to sine squared. I typed in sine squared. So there you go, kids. Like, if you want to get this stuff down, You're going to have to memorize a couple things. In addition to these, you're going to have to know that cosecant is 1 over sine. What else am I missing here? Cosine is 1 over secant. Tangent is 1 over cotangent. Those are the ones you have to know. And some of you do know those. If I've picked you, you've shown that you memorize it on a form quiz. So some of you do know that. 39, suppose P is directly proportional to Q and inversely proportional to R squared. So this is something that is not in the textbook that they paid a lot of money for us to use, and I haven't taught it, but it's direct and inverse variation. So direct variation, we have this little formula, y is kx, where k is a constant. In indirect, we have y equals k over x. And those are the setups for these things. So suppose P is directly proportional to Q. So P is some constant k times Q, and inversely, which is why I wrote indirect. I don't know why I wrote indirect. Inversely proportional to R squared. So inverse is a denominator idea. Direct is multiplication. There's my setup. P is KQ over R squared. When Q is 1, R is 2, P is 4. Now this text is given so that you can find K. Q is 1. K is not given. R is 2. P is 4. So this is going to give me a little equation that says 4 is equal to K over 4, which means that K has to be 16, because 16 over 4 is 4. What is the value of P if Q is 2? So P is this constant now, which is 16, times Q, which is up in the numerator, and it's 2 now, over 4 squared. So that's going to give me 32 over 16, which is 2. Be cool if you'd seen direct and inverse variation before, which you have not, because it's not in your textbook. And the last one on the test. What is the value of A plus B if 2, 1, 4 is a solution of the following system of equations? So this is not hard. They're literally giving you X, Y, and Z. It'd be nice. I guess you could probably use matrices to some degree, but there's no point. There's really no point. We're just going to plug things in. I notice this line is going to give me B. So 3 times a 2 minus 2 times a 1 plus 4 times a Z, which is 4. I don't know why I didn't love Z. 4 times a 4. Oh, man, I'm tired. Z is 4. 4 times a B is negative 4. So this is 6. 6 minus 2 is 4. 4 plus 4B is negative 4. 4B is negative 8 because we subtract 4. B is negative 2. Okay? Notice they want A plus B. So we're going to do the same thing now, but with the bottom equation. I'll put the 2 there, the 1 there, and the 4 there. Negative 2 times 2 plus 8 times 1 minus 5 times 4 must be negative 20. So I'll get a negative 4 plus an A minus a 20 is negative 20. 20's cancel. A is 4. And again, they want A plus B. So this is 4 plus a negative 2, which is 2. And that is the 2024 TMTA Algebra 2 Math Contest. I'm glad to be done with it because I got to focus on my classes. Maybe I'll do another one, maybe I won't. We'll see.